Hey guys, let me go ahead and get right into this. Now, I got a couple of windows open. I'm not gonna need them all. So listen, what you're looking at, they say that the path of the total solar eclipse is this little dark line going across there. Now I know you guys can't see my mouse pointer. Don't worry about it. I'm gonna do my best to describe as if you can see it. Now, if you look at the dark object traveling this little line, it says path of the solar eclipse. Everyone along inside of that line and that path will be seeing the total eclipse. Everyone outside of it, they will see a partial eclipse. This actually proves a close sun and moon above a flat plane, and I'm going to show you how before we get deep into this. Now, here's a model of what a total eclipse will look like if you're in that path of totality. So what's going to happen if you're in that, and I'm not going to be replaying this, so I'm going to need you guys to pay attention. You can replay the video afterwards. But if you're in that line that I just showed, if you're in that path, this is what you're going to see. You're going to see a full total eclipse where they completely align. But if you are not in that path, here is what you will see. For example, I'm here in Las Vegas, so this is what I will see. Since I'm not in that path, this is what I will see. I won't see the total eclipse. This is what's gonna be seen from Vegas, and I'm gonna explain why. You notice the difference? We don't see the full eclipse like I just showed you. You know why? Because if you go back to the map here, you can see if I'm standing down here in southern Nevada and I'm looking up at this path, then I will actually be looking inside of that alignment. Now, I don't want to confuse you. Close your eyes. Let me give you an example of what I'm talking about. When you think of an eclipse, think of two frisbees above your head. Think of one frisbee high above your head, one frisbee below that frisbee. Let's separate them. Let's separate them by like an arm length apart. Hey, maybe I can find an example on. Let me open up Paint, because I really want to describe this in a way that's visual. But if you think of two frisbees aligned above your head, and if you were to look directly up at those frisbees, you wouldn't be able to see but one of those frisbees, because the other one would be blocking the other one. But if you were to walk back, you would start to see the other frisbee, and you would start to see, yes, they are aligned, but you would be looking inside of that alignment. I don't know if you guys fully understand what I'm saying, so I'm opening up Paint right now to do a little demonstration. Like I said, I don't want to make this video over an hour, so let me try to demonstrate here what I'm saying. Just say that we are looking up. Let me get something. All right, let's fill with solid color. All right, stay with me, guys. Just say there's a frisbee. You know what? Let's outline this in white. That way it'll look a little better. Cool. All right, so you got one frisbee above your head. Okay. You have another frisbee below that. Okay. If you're standing down here, all right, and you're looking up at these frisbees, you would only see something that looks like, you would only see this. Okay? All right? So, let's do that again. All right? If you're standing beneath a disc, all right, and two discs are aligned in the case of the eclipse that's happening on a flat plane, because the way I'm showing you is a flat plane with the sun and moon above. And I'm using this because, I mean, how the hell do you make a spear on paint? This is a good example. All right, this would work the same with spears. So again, if these two spears are in alignment above your head and you're on that path, remember the path that they showed us. You have to be in the path of totality, meaning you have to be directly underneath this in order to see this total eclipse or the alignment where they become one. This is simple stuff that I'm showing you. Now, how would this look different? Well, if you're not in that path, even though the two may be aligned, if you were, for example, in Nevada looking up at the eclipse and looking up at the path, and you're not directly under this alignment, then it will appear something like this to you. It would probably appear something like that. You know, to where you can actually look inside of those alignments. In other words, you wouldn't look up and see a perfect circle standing from up under here if you're not directly up under it. If you're anywhere else, you're going to see a MasterCard symbol. Anywhere else is going to look similar to something like this. All right, just like we just saw. So if you're not directly under this thing, you're not going to see a perfect alignment like this. You'll see something like that. You'll see something like that or something like that. Doesn't mean it's not aligned perfectly. Just mean from where you're viewing it, you're viewing inside of this sandwich. Okay? I hope you guys understand how this works. Now, with that being said, let's go back to this. Excuse me. Let's go back to, again, if you're in Nevada, like I'm going to be looking across at the solar eclipse where the path of the total solar eclipse is, then you won't see a full alignment. Now, this proves that the sun and moon is close and that they're local and that we're not on a globe. Because what I'm going to do, if you saw my previous video, let me give you an example. Correct moon distance from Earth. All right, people are not using the right scale to teach this eclipse. They're using a version of Earth that shows the moon directly up on the Earth. And when you use that, you can make this eclipse work. This is what NASA and a lot of more people are using to demonstrate the eclipse, but this model is not the scale. So let's go to an accurate model that's to scale. Again, this is a model that's to scale. You can see how far apart the Earth and moon is. This is exactly how it would look if the moon was 238,000 miles away. Again, everyone on that side of the Earth would be in the path of totality. Let me repeat. Everyone on that side of the Earth would be in the path of totality. This path would, not only is this path local to one continent, but it's local to one area in that continent. This would only be possible if the sun and moon were close to Earth above a flat plane. And I'm going to demonstrate again by using the pictures again. Everyone on Earth, if the moon, for example, was this far away, everyone on Earth would see the eclipse happen this way. And we would all see it roughly around the same time. Remember, on a globe, the sun is on one side, the moon is on the other side, giving some one night, some one day. So you wouldn't have these type of phenomena on a globe. You wouldn't have it working that way. This is explained perfectly on a flat Earth. Now I'm going to go ahead and wrap this up. But again, everyone on a globe would see this total eclipse if this were the case. All right. So let me close that up and let's see what else I got open here. So again, from Vegas, this is what I'm going to see. It doesn't mean that they're not in alignment. You got to ask yourself a question, okay? At this point in Vegas, when I'm looking at these objects like this, it's the same exact point in, let's say, Idaho or Montana, one of these states in the path of the total solar eclipse. If you're in that path, the moment people in Vegas are seeing this thing aligned partially, you will be seeing it aligned totally. Now, people in Vegas who are seeing this alignment that's not fully in alignment, it's kind of a MasterCard symbol or kind of a, you know, a little bit more than a half partial alignment. It doesn't mean that those objects aren't accurately aligned 100%. It just means that while they are fully aligned, like you see here, they are fully aligned on that path of the total solar eclipse as you see on this map. Everyone else to the left of that path and to the right of that path, for example, again, if you're in Vegas with me, you're going to see it happen this way. And again, it goes back to the demonstration I did in paint. It's not that these objects aren't aligned. It's that we're looking into the alignment. We're actually looking from a side view at the alignment as they pass across, what is that, Oregon, Idaho, Montana, Nebraska, as they make their way all the way out to North Carolina on the East Coast. All right, everyone, like, for example, when this thing hits North Carolina here on the East Coast, people that's directly under this thing here in North Carolina, they're going to see a total eclipse, all right, just like you see there. But let's just say you're here in Georgia and you're looking over at the eclipse, you're looking up and over at it, and it's not directly above your head, it's going to look something like that. This is simple stuff that I'm describing to you. If you want to demonstrate this in your house, take a stick that's taller than you, attach 2 frisbees to it, align those frisbees above your head to that stick, stand up under it and look up. You will see one frisbee because the other one is blocking. Now walk away from the stick and the frisbees. You will begin to see both of those frisbees, but you will begin to see the other frisbee be revealed just like you see in this demonstration here. Piece by piece, portion by portion, like the MasterCard symbol. Now, if you go back up under that stick, all right, and look up, you will see it this way. But once you walk from under that stick and you look up and over at it, you'll see it like this. So this explains why it's a local path of totality. You know, this cannot be possible on a globe whatsoever with the moon that far away. You wouldn't have this much of a local phenomena. All right. We're talking local, meaning this thing is limited to one continent, but it's actually local within that one continent, meaning not only is it going to be limited to the USA, not even everyone in the USA is going to be able to see the total eclipse, because this is a very local phenomenon. The sun and moon are local objects, just as I'm explaining. So to make this quick, I think you pretty much get my drift. There's some more things I want to point out, some nails in the coffins where they pretty much shot themselves in the foot before I close this out, because I want to make this short. Now here's a day and night map of the world. This shows the correct position of the sun and moon as I speak right now. Let me refresh this because time have changed since I opened this. So let's see exactly where the sun and moon is now. I'm trying to finish this before this thing reach Oregon. It'll reach Oregon at 9 o'clock and then we'll start having this phenomena happen. So I woke up early to do this stream just to expose them once again. But if my computer hurry up and refresh this page, I can show you what I mean. Anyway, while we wait on that to load, let's go to something else, because there's a lot of things I have open, and there's a lot I want to share with you, and I'm going to let you guys go. So You see that they are going to big efforts to get everyone in alignment with their time zone when they're going to be able to see it. But again, they're proving flat earth when they do that. I'm going to also show you another thing where NASA shot themselves in the foot. NASA is actually going to be following the eclipse in a plane. And you know that's only possible on a flat earth with a close sun and moon. They have plenty explanations on why there are different durations of totality at different places in the path, and they're all baloney. A third grade can debunk them because there's really no way to explain why there would be different durations of totality at different places in the path if you're on a globe. However, it can be easily explained above a flat plane. If you haven't saw my previous video on this, it'll go into it a little deeper. So yes, you know, one thing I wanted to show you, doggone it, real quick. I hope I didn't lose it. I may have. I had a window open, right? And NASA is going to be in a plane tracking the eclipse from Oregon to, what was that state again? From Oregon, it's going to start in Oregon. It's going to end here in, that's West Virginia. So they're actually going to get in a plane and follow the eclipse. So what NASA is going to do when this thing when the total eclipse starts in Oregon, they're going to follow that total eclipse and that whole path to Virginia there. And by the time it exits, it'll be dissipating, meaning that the sun and moon will be separating again. Now, why is this important? Because in order for them to follow this solar eclipse and stay looking at the total eclipse, meaning if they follow this eclipse and it looked like this the whole trip, it proves flat earth. It definitely proves flat earth. Because if they're following this eclipse, for example, if you're in Oregon, when the path of totality is above head, you're going to see a perfect eclipse, perfect circle, perfect alignment. Now, to you Oregoners, prove me wrong. When this thing leaves Oregon and ends up in Idaho, Montana there, people in Oregon are going to start seeing the eclipse like people in Vegas. I closed the screen, but it's not going to be total. In other words, as they move away from you, it's going to look like you see here. Not mean that they're not aligned. It just means that any two objects that's in perfect alignment above your head, you're only going to see one of them like this. But if they move away from you, you'll start to look inside of this little crack and see the gap inside, and it'll look like this. So this is what that's going to look like to the Oregoners. I'm saying Oregoners, I'm making that up. This is what it's going to look like to people in Oregon as it moves away. Now, if NASA is following this eclipse and they're seeing a total eclipse the whole way from Oregon to Virginia, it proves that these objects are local. They're not 238,000 miles away, 93 million miles away, if you can follow the totality. All right? If they can think about what I'm saying, in order for you to see this, you have to be directly underneath it. So if NASA is traveling from Oregon to Virginia and they're recording this, what you see here direct, that means they're traveling directly underneath it. If you were on a globe with the moon 250,000 miles away, there's no way you can follow an eclipse and remain directly underneath it the whole trip, people. It's impossible. This proves we're on a flat earth with a close sun and moon. So think about what I'm saying here. Prove me wrong. Put it to the test. I obviously can go deeper and deeper and explain this deeper, but I think you smart people get it. If you don't, just rewind the video, because I didn't want to make this video past 30 minutes. If there's something that you don't understand, get in the comment section and I'll do another video after the eclipse answering any questions or loose ends that I confuse you with. So I hope I did a good job simplifying it. I'm going to close all of this stuff up And let me make sure there was nothing else. Had quite a bit of tabs open. And let me make sure there was nothing else, because often I forget stuff. Hey, let's check out this video before I go. I opened this minute video and I never even checked it out. So let's watch it together real quick before we get out of here. So I'm glad I played this video. They're basically laughing at us. Think about what they just proved what I just talked to you. Now, I haven't even watched this video, but they just proved what I just demonstrated, and I'm going to show you how. Check it out. I'm going to go ahead and mute that because the music is corny, and plus I need to talk to you. Again, like I said, for them to chase this solar eclipse and remain at the path of totality, meaning that for NASA to chase this solar eclipse across the United States and remain seeing a perfect alignment the whole trip, it means that they're remaining directly under these objects the whole trip. And there's no way that NASA would be able to trace a total eclipse across the United States and remain directly aligned underneath it if the sun and moon were as far away as they're telling us. They would never be able to chase a solar eclipse, and every time think about it. And I'm gonna show you what I mean. I'm gonna play some more so you can see what I mean. So the total eclipse will last 2.5 minutes. Now it'll only last 2.5 minutes for people who are in Oregon. Damn it, I'll just close my map out. Well, here's another map. Okay, good. So for you people in Oregon, in other words, any place you're at in Oregon, you're going to only observe this for 2.5 minutes. All right. So depending on where you're at, in other words, it's only going to be directly above your head for 2.5 minutes, meaning you're only going to see a perfect alignment for 2.5 minutes. But you people in Oregon, if you get in your car, and you can just say if you had a car with no traffic and it was just a clear plane for you to drive in, you can actually do what NASA is doing on the ground. All right, I don't know how many miles per hour you would have to go to keep up, but you can drive clean across the United States and stay directly under the sun and moon and always see this alignment. And that wouldn't be possible on a globe. Just the fact that you can locally trace these things and chase them and stay up under it and they won't get away from you proves that you're following this alignment, because if you look up and see a total eclipse, they're perfectly aligned. Everyone that this total eclipse passes, they would see a Vesica Pisces or like the MasterCard symbol like I described previously. So this is what NASA is telling you. For regular people like me and you who don't got a jet plane, it's only going to last 2.5 minutes, because once it align above our head, that's it. When it leaves us, we're going to go in the house and we're going to clap our hands and say, yay, we saw the eclipse. But if we want to keep seeing this alignment, all we got to do is get in the car and go to the place on the map where it's going and get up under it again, and you will see the perfect alignment again. It's not that the sun and moon are separating because it's leaving Oregon. They're still aligned when they get to Idaho here, because the people in Idaho is going to see what you just saw when it get directly above their head. They're going to say, ooh wee, look at the perfect alignment. While the people in Oregon are now saying, hey, it's no longer aligned anymore because it's no longer directly above your head. So for NASA, since they got expensive jet planes that's fast as hell, they can actually follow this thing and it can always be directly beneath it, watching this total eclipse. So pay attention to what they're telling you here. NASA jets will be chasing an eclipse across the U.S. The total eclipse will last less than 2.5 minutes for regular people like me and you. But for NASA scientists, it will last over 7 minutes. I don't know how long they tracking it, but they tracking it long enough to see what I'm saying here, because the planes will chase the shadow of the moon as it moves across the states. This proves my point. Telescopes on the plane will capture the clearest images of the sun corona to date. And the first ever thermal images of Mercury, which is a bunch of CGI bullshit, probably some vomit, excuse my language, guys, on the ground, a stretch of land about 70 miles wide, blase, blase. This is known as the path of totality. Look at this diagram. They would never be able to trace this path without using this deceptive diagram. So the only way they can make this work is by pulling up the diagram you just saw, and I accuse them of deception when they do that. Again, the diagram they're using to say they're chasing this shadow of the moon is a bogus diagram that puts the moon directly in front of the earth, and we know that that's not true. So this is the diagram they're using here. I'm sorry that it's blurred. It's blurred because it's on pause. And in this diagram, it can happen perfectly. You can be on a jet plane chasing this thing locally across the states. But if you think about what I said earlier, if you deal with the correct distance of the moon from Earth, there's no way, all right, you can trace this thing across a continent with the Earth and moon this far divided. So anybody that explains this phenomena to you in any way, they're going to have to use the bogus model here like NASA is doing. So remember everything I said in this video, soak it in. This stuff is easily debunkable, and I'm going to let you go after I go over this chart. Again, this is the one we was waiting to load, and this shows the position of the sun and moon. Right now, they're roughly aligning above Africa, but as you can see, the sun isn't perfectly in front of the moon yet. By the time the sun and moon works its way in front of North America here, they would be in alignment. So this is why we would see the eclipse in North America only. By the time they get to us, the sun would be just about coming in front of the moon. So this is a local phenomenon. Even the scale of this map we're looking at is suitable for the flat earth cosmology, as opposed to the globe, which has the moon far as hell away, and that would be a small dot representation on this map. So the scale matters in this experiment, and I hope that you guys replay and see what I'm talking about. This is a nail in the coffin for the globe. Rest in peace, Dick Gregory. Shout out to all flat earthers on this flat plane. I love you all. Share this video with everyone you know, because man, we're doing great work proving flat earth. And also, if you haven't saw my previous video on the eclipse, make sure you do so. So with everything being said, I'm gonna let you guys go. I didn't have time to look at the chat room, so I guess before I go, I'll give some more shout outs. Sure. And I hope you guys enjoy your eclipse today. Let me make an announcement to people who live in Las Vegas. If you want to watch the eclipse with Brother Sanchez, I'm going to be watching it from the Durango Lounge. Again, the eclipse will start around 10:20, roughly 10:30. You want to be looking up at around 10 o'clock to 11 o'clock so you don't miss it. But if you live in Las Vegas and you sent me an email and you're not watching this stream, well, actually, I'll email everyone who emailed me. I will be at the Durango Lounge. Get on your smartphones and Google the address. You can meet me there. I will be shaking hands, flat power, Las Vegas. To all of my Las Vegas flat earthers, we're going to make it a flat earth eclipse meetup here in Vegas. I will be at the Durango Lounge. So Google the Durango Lounge, get the address, let the lady GPS tell you how to make it there. Make sure you be there at 10 o'clock to 11. I'll be there for 30 minutes watching the eclipse, shaking hands. So if you want to meet me and you live in Vegas, Durango Lounge. As for everyone else, please hit the thumbs up, like button, share this, because the globe has been debunked once again. Flat power. Have a nice day.